This is lesson 36, which is VHDL example 20. And in this lesson we're going to design the 4-bit comparator that we designed in lesson 35 by cascading 4 1-bit comparators. But in this case we're going to use a VHDL procedure. We'll see how that works. You remember from the last lesson we designed this 1-bit comparator. We made this truth table, and then by using Carnot maps you could get these 3 logic equations for G out, E out, and L out. So we're going to use those to make a 1-bit comparator and then instantiate 4 copies of it. So this is going to be our 4-bit comparator, 4 1-bit comparators. Now, to do this in VHDL, it looks as if a for loop might work. Remember, when you go through a for loop, it makes multiple copies of the circuit. And here we want to make 4 copies of the same thing. So the question is, how can we use a for loop to do this? And we're going to use a VHDL procedure. Here's the general form of a procedure. It's the word procedure followed by some identifier. And then this parameter list is essentially the same as in a port map in the entity. That'll just give the inputs and outputs. And then you have is, the declarations, begin, end procedure, and then your sequential statements in here. Well, let's see how it works. We're going to make a 4-bit comparator. X is 3 down to 0, x3, x2, x1, x0. Y is the 4-bit input, y3, y2, y1, y0. And then the outputs are greater than, equal, or less than. Greater than, equal, or less than. So, here's how you do it. In the architecture, after the word is and before the begin of the architecture, where you normally put your component declarations, we're going to put the word procedure comp 1-bit. So we're defining this 1-bit comparator that we designed. The inputs are X, Y, G in, and L in. Those are of type standard logic, single bits. And the output is G out, L out, and E out. So this is what we're making. And all we do in the begin, between begin and end procedure, is write down the logic equation for G out, for E out, and for L out that we got from the Carnot maps. So this defines this 1-bit comparator that we called comp 1-bit. Well, then in the main part of the architecture, we have a process XY. This is the inputs X3, X2, X1, X0, Y3, Y2, Y1, Y0. And we'll define a variables G, L, and E, 5 down to 0. So we have G4, G3, G2, G1, G0, L4, L3, L2, L1, L0. And we'll also include E4, E3, E2, E1, and E0. Now, of course, we don't use the lower 4 ones. We're only going to use E4 when it comes out. So how does the algorithm work? Well, you remember we set G0 and L0 to 0. And then we just go through a for loop 4 times. For I equals 0 to 3 loop, first time through I is equal to 0. So the parameters of comp 1-bit are just going to be x0, y0, g0, and l0. That's x0, y0, g0, and l0. And the outputs are gi plus 1, which would be g1, L1, and E1. G1, L1, and E1, which we don't connect anything. Well, we just keep going around the loop. So the first time through we made this component. Next time through I is equal to 1. So the inputs are x1, y1, g1, and l1. x1, y1, g1, and l1. And the outputs are g2, L2, and E2. G2, L2, and the E2 doesn't get connected. Third time through the loop, I is equal to 2. The inputs are x2, y2, g2, L2, x2, y2, g2, and L2. Outputs g3, L3, and E3. And then the fourth time through, I is equal to 3. So we have X3, Y3, G3, and L3 as inputs, and the outputs are G4, L4, and E4. Well, we've made all four of them now, so greater than is just going to be G4, the equal is the E4, and less than is the L4. So that's it. We've made this 4-bit comparator using this procedure, comp 1 bit, that we just called 4 times. We could simulate it to see that it works. Let's make X go from 0 to F using the counter. We'll set Y to 7. When X is 0 to 6, it's less than Y here. When it's equal to 7, it's equal to Y. And when it's 8 to F, it's greater than Y. So in fact it works. You can look at the details of what's in G, L, and E for each step along the way and verify how the circuit works. Let's make a top-level design with the 8 switches, and we'll compare the top 4 switches to the lower 4 switches. We'll compare them, and for the 3 LEDs, we'll connect those to less than, equal, and greater than. So here's the comp 4 that we had. 3-bit, 3 down to 0 for X, 3 down to 0 for Y. The outputs will be greater than, equal, less than. That's the component. And then we just port map it. We'll connect X to the upper 4 switches, Y to the lower 4 switches, and we'll make LD0 greater than, LD1 equal, and LD2 less than. So you can download this program to your FPG board, and as you change the upper switches and the lower switches, you can observe the LEDs and verify that you either get greater than, equal, or less than for the 4-bit comparator.